In this video, we will investigate a data set in CODAP about 2,201 individuals involved in a historic event. The data set provides 4 categorical attributes of the individuals: gender, class, which includes first class, second class, third class, and crew members, age classification, adult or child, and whether the individual survived the event. As we explore the data, think about the relationships between the attributes. At the end of the exploration, we'll ask you to make an educated guess about what the event was. Let's begin by investigating the attribute class through a bin plot. To do so, click on Graph in the toolbar. Resize the graph to make it bigger by dragging a corner. Now drag and drop the class attribute to the horizontal axis to make the plot. Since class is a categorical attribute, CODAP automatically makes a bin plot with a separate bin for each category of the class attribute and a dot for each case. Rearrange the categories of the class attribute by clicking and dragging. For example, click on crew and drag to the right of third class, so the class categories begin with first class and continue through crew. This bin plot shows that there were many more crew and third class individuals than first and second class. Using the ruler menu, we can select count and percent to learn more about the distribution of individuals across the classes. For example, we can see that 325, or 15% of the individuals, were in the first class. To investigate whether there is a relationship between survival rate and class, we want to look at the breakdown of class by whether they survived or not. Drag and drop the survived attribute to the graph's vertical axis. This creates a two-way binned plot. This representation is similar to a two-way table, also known as a contingency table, where the cases are placed into distinct bins, according to both categorical variables. However, each individual case is displayed as a dot, so we call it a two-way binned plot. When we make a two-way binned plot, CODAP initially displays row percents by default. This means that one should interpret the percent as a part of all the data in that row. For example, looking at the top right cell for individuals that were in the crew and did not survive, we see the percent 45 displayed. Since the top row is for those that did not survive the event, this percent is calculated based on using the total number of non-survivors as the whole. So the 45% in the top right cell means 45% of the individuals that did not survive were from the crew. Moving to the top left cell, you can also see that in contrast, 8% of the non-survivors were in first class. Since row percents use the condition of their row in their calculation, rather than the overall total, they are an example of conditional relative frequencies. Take a moment to compare the percentages of each class in the survivors and non-survivors of this event. By clicking on the graph and opening the ruler menu, we can modify the percentages displayed by choosing column percent. Note that the percent displayed in the upper right cell has changed from 45% to 76%. Now we should interpret the percent shown with the whole being the total number of cases in that column. So the 76% means that for all the individuals in the crew, 76% did not survive. Like row percentages, column percentages are also conditional relative frequencies. Now take a moment to compare the survival rates by class. Are you starting to have any ideas about what this event is? If we again return to the ruler menu, we can change to display cell percents. Cell percent should be interpreted as what portion of all the data in the cases in that cell represent. Again, returning to the upper right cell, the 31% now displayed there means that 31% of all the individuals in this incident were crew and did not survive. In curriculum materials, cell percents are often called joint relative frequencies. All the cell percents should sum to 100%. However, the percents in CODAP are rounded to the nearest whole number, which sometimes affects this property. Other important percentages to consider when analyzing bivariate categorical data are the marginal relative frequencies. Marginal relative frequencies may be calculated by summing individual cell percents across a row or column. For example, we could sum the cell percents of 24% and 8% in the third column to determine that 32% of the individuals were third class. Another way to find the marginal relative frequencies in CODAP is by removing an attribute. If we click on the survived on the vertical axis and choose Remove Attribute, the graph returns to its original form, where we can verify 32% of the individuals were third class.